Okay. So thank you very much for staying with us. My name's Doug Waters and I work for Uniper. And Uniper is a power generation company, so slightly different to some of the other people on the panel. We have about 40 gigawatts of power plant spread across Northern Europe and Russia. And we've seen a lot of these things happen over the last 15 years to us. So I've personally worked in power stations that have gone from base load to 200 or 300 starts per year. And I'm going to summarize some of the things that we've seen and also then some of the work we've been doing in Andhra Pradesh on this topic. So with KPMG and through the UK DFID organisation, we've done some work on how to improve the flexibilization of coal plants in Andhra Pradesh. So we have an ongoing program there. So I'm going to describe a bit about the work we've done there and Uniper's experience in flexibilization, then what we did at a particular power station in Andhra Pradesh and some recommendations to deliver flexibility, and now that's moving into the implementation phase. And then I'll look finally, and this is the work that KPMG do as part of this project, we tend to lead on the O&M and the engineering, they do all the market and the policy piece, but they've come up with some policy and regulatory enablers to make flexibility happen. So, a very quick overview of the situation in Andhra Pradesh. So that is one of the highest renewable intensive states in India. So this graphic is just showing you that it's at the top end of India in terms of renewable penetration, which means that some coal plant is going to have to flex there before in other areas. So KPMG did quite a big market study looking at what was going to happen. So there's going to be some increase in thermal capacity over the period, but significant increase in renewables across the period considered. What the model does is it calculates the residual generation shape for the thermal assets. So it doesn't look to curtail renewables. It looks to meet demand by putting all the renewables on and then meeting the rest by coal. And what that showed was that the coal plants are going to have to reduce their minimum load eventually down to 35%, not immediately down to 35%, but as more renewables happens, they need to go further and further in that direction. They need to improve those ramp rates to meet that duck curve profile that you saw earlier. And ultimately, they're going to have to start two-shift operations, so that's daily cycling. So that's the market requirement that they came up with, and there's lots more in the information pack that you'll find after this. So just a bit about Uniper and its experience in FlexOps, which is why we sort of got involved in this. So I've worked at a number of power stations and all of them have eventually had to lead to flexible operation. And when you run a power plant, these are some of the things you start to think about in your head. What damage am I going to do? And that's where the EPRI guys do a lot of work on the material side. What risks am I going to put myself into? So as Nilesh said, there's new risks coming along with this. What are my process safety risks? Because I'm asking this thing that was built to run base load to do something that it wasn't designed for. What's it going to cost me? What's the damage going to be? How good are my people? What's the grid code going to require? And ultimately at the bottom there, how am I going to get paid for it? And I think that's the key issue in all markets. How are you going to pay for flexibility? Not, can I do it? Because as someone said earlier, you can do anything. It just costs money. But ultimately, someone's got to pay for it. So, within Uniper, we have a kind of flexibility process toolkit, okay, which is what some of the guys were talking about before. This is ours. So it has sort of 6 main areas. The first one is, what's my market requirement? So, as we saw in Andhra Pradesh, it's to lower the minimum load and then use that learning to eventually move into two-shift operation, okay? So we're not going for straight two-shift operation, we're going for reducing our minimum load, and ultimately we're going to go for two-shift operation. The next thing is, what do I know about my power station? So those are the kind of reviews and so on that Steve and Nilesh were talking about. What's my existing power plant potential to deliver? And most coal-fired power stations have huge potential to deliver flexibility. They might need some limited capital investment, but as people have said before, there's limited money to spend on that. But you can do a lot with the plant you have. But then you need to look at how am I operating my plant? So if you think about not the plant, but then the process. So what do my startups look like? How do I control flame stability? How do I lower my minimum load? Which mill groups do I have in service? All of those things. So you need to go through the operational procedures. And that's where a lot of the changes come in. Then you need to do some work on performance monitoring, which is what the guys talked about before. So how am I going to capture all this data, and how am I going to use it very quickly to make decisions and manage risks? So it's no good having a report produced in 2 weeks later. You need it right up in front of the unit operator's eyes. Then into the kind of softer ends, but these are the bits where success happens. So what's my culture in my power plant about delivering this? If people don't believe it can happen, then your unit operators won't deliver it. So there needs to be some leadership and some real engagement with the staff. And then it's not a big leap delivering flexible operation. It's small incremental steps. So within Uniper, we say it's a journey, it's not a destination. So eventually, you will get better and better at it. So these are some of the things we've done in Uniper and our different plants from the UK to Germany all the way through to Russia. So faster onto the grid, cheaper to start, faster to full load, cheaper to run, and faster off, and then warmer for longer for the next start. Now, you don't do all of those things in one power plant. You do them relative to the market that they operate in. So what's important in the market? So now a few case studies. So this is a 4x500 subcritical power plant in the UK, and it's 60 years old, or over 60 years old, and it's done nearly 3.5 times its design life in terms of hours and starts. So you can see in its early life, it was running base load. So this graph is showing you the starts per month across the 4 units, and you can see for the first 20-something years, it ran base load. There was the miners' strike in the UK when there wasn't the coal around, so then it did lots of starting and stopping, but then it went back to base load. And this is when our experience with flexible operations started, in the 1990s. So as in the US example, gas became cheap very, very quickly. So the coal plant got forced to the margin. And so you can see there we're doing, 15 starts per unit per month, okay? So 3 times a week. And then renewables started happening, and you can see the starts and the stops get hugely volatile. So that's a mix of renewables, gas, all pushing coal to the margin, and then gas gets expensive, so coal goes first. And so there you can see we go very, very volatile. And in the recent period, it's gone extremely volatile. So what looks like base load on that bottom right-hand corner is actually periods where we go cold for a period on maybe 2 or 3 units. So 2 or 3 units will be cold in the summer. In the winter, which is the peak demand in the UK, all the units come back into service. But they need to be able to start reliably. So now we're doing around about 100 starts across the 4 units per month. So that's about 25 per unit. So every working day, and cold at the weekend, as someone said. This is a different example in Germany. So this is a supercritical coal-fired plant, quite modern by coal-fired plant standards in Europe, 1987. Currently 920 megawatts, and it has a minimum load of 11%, which we achieve on 1 mil with no oil support. Now, we didn't go there straight away. That was a 2-year program of work involving lots of testing, risk assessment, and so on. And what this unit does is we need 1 hour's notice to come down because we have to get the temperatures down in the boiler. So that's the initial drop-off you see there. And then we can come down for up to 8 hours, down to 11%. But what must happen, and the grid company needs to understand that, we must come up to 50% load for 3 hours in order to soot blow the boiler, because at that very, very low load, you basically can't do any soot blowing, so you've really fouled up your boiler, okay? So that shows what is possible when you spend time and thinking about it. Very little capital modification to this plant, maybe a few €100,000 of expenditure to achieve this, but lots of training, and lots of risk assessment and lots of engineering. So, more into the Indian context. So with KPMG and with the UK government, we've been looking at SDS thermal power station, which is a very modern 2x800 megawatt supercritical power plant. Design minimum load 55%, which is typical in India. Very low ramp rates by European standards, and faces a number of key issues. So, as with many plants in India, shortage of coal, quality of coal, and the control system's never been tuned below about 60% because it's been running base load. So it's achieved by sort of testing and by doing it itself, around 320 megawatts. But they wanted to know how could they go down regularly for longer, and what was the risk going to be, and what was it going to mean for the longer term. So this project split into 3 focus areas. So the first one is reducing minimum load, the next one is increasing ramp rates, and the final one is about 2-shift operation. Now, in discussions with KPMG, the reduction in technical minimum was going to be our first starting point, because that's the immediate requirement in that area. So what we learn there, we can then particularly apply in the 2-shifting scenario later. So it's a kind of evolution of a power plant. It's not doing everything all together. And you can see there, these are all the roadblocks that we identified with them in terms of delivering that. So coal quality, tuning of the combustion. So you can read all of that, and those are the things we need to solve before we can release the unit to do other things. So again, we used the Uniper sort of flexible operations model and worked with the power plant to work out when we were going to intervene and what we were going to do. So a lot of it is on the plant and the process. So how are we going to deal with coal quality, flame stability, low back-end temperatures, issues with the turbine-driven feed pump, etc. So all those issues were captured, and then we come up with a mitigation plan. The other thing that became quite apparent is when you do lots of flexible operations, you need to be able to raise your maintenance defects very quickly, because you need to get that opportunity maintenance done when you have periods when you're not required. So this plant didn't have a suitable computerized maintenance management system for that, and that as a sort of fellow operator of power plants, we felt that was one of the key things that they could really benefit from. And then on the people front, really need some training programs with the operators. The operators have never seen that type of environment, and about 50% of flexible operations sits in your unit operator's hands. So you need to be able to train them in simulators or in scenarios, what's going to happen, what you've got to do. So a couple of quick examples. For coal quality and flame stability, we basically said, okay, there's some issues there. We can spend lots of money, or we can spend not very much money. But let's start by spending not much money and see where we get with the solutions. So the first one is about blending coal and buying new coals and using the fairly crude blending facilities they have on site. And if that doesn't deliver the benefits we need, then we'll go for a full blending facility on site, which will take a lot more money and take a lot more time. Also about sampling system. If you know what's coming to your boiler, then you know what the issues are going to be. And finally, as been mentioned before, flame detection wasn't adequate, we felt, for what was there. Next one about maintenance management system. I won't go into any detail on that, but essentially we recommended that they needed to install a new one. And then on training. So Uniper trains many of the operators in the UK for our own power plants and all our competitors. And so we're going to develop some training packages for the guys out here in India in order to deliver that flexible operation. And then there was a lot of interest in going straight for single mill operation, and we explained that's not the way you do it. You start with your current position and you work down through numbers of mill groups. So the first implementation target is for 280 megawatts using 3 mills, and that's being planned at the moment. So there's a number of actions that need to be done there, risk assessed and sign off in order to release that unit for 3 mill operation at 280 megawatts. After we're comfortable with that, which might take 3 or 4 months, we then move on to the next target and all the way along. That's why in Germany it took 2 years to get down to single mill operation. Final slide is just on key enablers for incentivizing flexibilization. So this is more on the KPMG side of the project. There needs to be some regulations for defining what you mean by minimum load, both in the market and technically, and in terms of emissions compliance and all those things. Key important one is there needs to be some form of economic incentive in India for people to operate flexibly. Currently, a lot of plant are just paid on energy through a PPA, maybe with some adjusters for heat rate and things in there. There needs to be faster scheduling intervals. You heard about 5-minute balancing. Some countries are talking about going to 1-minute balancing now, okay? You're not going to go straight there in India, but you might go for half an hour to start with. And ancillary services, what do we mean by ancillary services? Because every grid code has different meanings. And what do we need to deliver in India? The whole market design, so you need to move away from a PPA type structure into some form of wholesale traded market that provides incentives for behaviour. And the final thing is some sort of code for the power plants to follow in standard operating procedures for flexible operation. Now, whether that's across a fleet of power plants or a different type of power plant, it doesn't really matter, but there needs to be some rules, because if it goes wrong, it goes badly wrong. And so you want to avoid those things. And that's it.